Okay, state the appropriate magnitude of charge and mass of proton alpha particle in terms of charge, mass, m of electron respectively. Okay, you have given electron, mass m, charge minus q, specific charge m over q. Sorry, not specific charge m over q is m over q. So proton is what? Roughly can remember your AS work?
Proton?
Yep. The mass in terms of m, 2000 times. Charge, what's the charge?
Uh, 1.6 times 10 to the power negative 19.
No, in terms of q. In
Oh,
terms
in terms of Q.
of q. Q is the charge of electron, whereas q is the charge. Positive, positive q,
Oh, okay, yeah.
right? M over q is 2000 m over q, alpha, 2 proton, 2 neutron. So what should it be?
Two
About,
proton.
we don't want exact answer, we want about 2 proton, 2 neutron. So 1 proton is 2000, neutron is 2000, so 8000. No? What is the charge?
Posit plus 2Q.
Q, okay, good. M over q.
1000.
Okay, you should be able to sketch the path of electron, proton, alpha entering at normal insert the magnetic field. The magnetic field is to the page. Right? Magnetic field is to the page. Current is the flow of positive charge. So where's the force? Force on the positive charge on the proton. You should be able to
Force
where's the force on
up.
up. So you should be able to draw the graph. Gamma not deflected. There's a proton. There's an electron. And there's an alpha. Maybe proton should be more curved. Lah. Okay. And
Yes.
you should be able to draw all that. Electron is deflected very easily because of the small mass.
Teacher,
Yeah.
do you know when does the A2 exam ends?
A2 exam end. It changes, I think, by December, by early December should finish.
Oh, guaranteed early December.
That one you have to check with your teacher. Lah.
Oh, okay.
Or go to the web page and check whether the timetable, CIE timetable out or not. If you are required to draw, then you have to bring your compass or use coin if you don't have compass. Right? There's a beta, there's a alpha. Right? It's a arc of a circle lah. Okay, try this one. A beam of electron move at 4 times 10 to the power 6 meter per second perpendicular to a magnetic field of 0.5 millitesla. Calculate the force on the electron in the beam. See whether you can get the answer or not. Can get or not?
Yeah, I'm calculating. Wait, force of what? Force on each electron.
Ah, charge you can get lah. Charge.
Is it the BQV one?
BQV lor. That's a charge an electron you can get from data sheet.
Oh, 3.2.
3.2 times 10 to the power minus 60 Newton. Radius of the circular path of electron. Assume it is in vacuum.
Is it the MV over QB? Wait,
Yep. Magnetic force
4.5.
equals to magnetic force equals to electric force equals to centripetal force. So yeah, you have to state earlier. Electric force. Sorry, magnetic force equals centripetal force. And then derive the equation. Don't memorize the equation. Then mass you can get from data sheet. Mass of electron. Speed is given. Speed given.
0.0456. Yeah.
Okay. Radius of beam of alpha particle can move into the same field with the velocity of 800 meters per second. Right? Same equation. Calculate out. Right? All these things should be able to calculate out. Right? Atomic mass unit. Right? Make sure you know how to find your atomic mass unit. That is your atomic mass unit. Mass of neutron.
3.34.
Yep.
Is it 3.34?
3.34. You
Times
missed.
10 power 22.
Okay. You should be able to fill up this table. Your AS work. Charge on beta. The charge on alpha is 2e. Speed of alpha. C is the speed of light. What's your beta? Mass of alpha. Approximate value. Should be able to fill up this table. Can.
Okay.
Can. Can or not? Can or not? Should be able to fill up
Yeah.
this.
Because gamma is the speed of light, right?
Yeah. Speed of light. C. Okay, let's continue on. What happened to stationary charge in a magnetic field? Yep. What happened to the stationary charge in a magnetic field?
Uh, wait, is it nothing?
Stationary, remain stationary, lor. Nothing, lor. Right? Not affected. It's only thing that when it's moving at an angle to the field, is affected by magnetic field. What happened to a positive charge moving in the direction of magnetic field?
Is it also nothing? I just continue only.
Continue with the same speed, lor, or same velocity, lor. Not deflected.
Same direction also, right?
Same direction, uniform
Same
velocity.
direction, same magnitude. Okay.
Ah, not affected lah, unless it's at an angle. What is the force on the positive charge Q moving with velocity v at right angle to the magnetic line of force of strength B? It's just to test your memory of the formula. Yep.
What's the force? Is it nothing also?
No, there's a magnet.
Oh, oh yeah, yeah. It has a right angle.
Right? F is BQV. Since the force is always perpendicular to the velocity, what type of path is the motion?
What's the word?
Parabolic, circular.
I think it's a circular.
Circular path. As long as the force is perpendicular to velocity, always. If the positive charged particle is moving into the page and the magnetic field strength is vertically downwards, show the direction of the force acting on the charge. The direction of the force.
Direction of force.
U is going downwards.
It's going. Okay.
This one is a bit harder to adjust.
Uh,
U is going downwards. Current is moving. Positive charge moving in. So it's either left or right only. Downwards is taken by V. Inwards is taken by current or motion of the charge. So where's the
looks like a right.
Are you sure?
Wait, wait.
There's the field. There's the current. Can see my fingers.
And there's no way it's down. I see it's down.
The field is down. Current is into the phase.
Or currents into the page.
Ah, right. Field,
Into the
current.
page. That's left. Yeah, left.
Ah, left. Lor. Force is to the left. This one should be able to calculate a proton or mass of speed 1 times 10 to the power 6 move perpendicular to a uniform magnetic field of strength 30 millitesla. Find the magnitude of the force. Can get.
Uh,
Why take so long? PQB là sao à?
4.8.
4.8 times 10 to the power minus 15. Acceleration on the proton is to get you to use a data sheet. Know where to find your mass of proton. Know your AS work.
Using F equals MA.
F equals MA.
Uh,
Can.
2.87. Yeah, correct.
Okay. Okay. Atom of neon 20 are ionized by removal of one electron from each atom. For neon 20 ion, state the charge on the ion. Right? This is a bit of AS work, or mainly AS work. Right? Charge on the ion, positive or negative. Right?
Oh, just positive or negative?
Remove an electron. Right?
Still positive.
It becomes positive. One positive charge.
Oh,
Calculate its mass.
whole number or in terms of n?
This one you have to use data sheet really.
Okay.
There's a data sheet. There's a data sheet. Rest mass of,
So I
rest mass of proton there. Okay.
so I take 20 times mass of proton. Then I get 3.34
That's
times
all.
10.
Make sure
Uh,
you know where to find your value.
okay, what's Avogadro constant again? I forgot.
This one is used in Avogadro's constant is this number.
Is it the ideal gas chapter?
Ideal gas, yeah.
Oh, okay.
Right? This Avogadro's number. The Avogadro's constant 6.02 times 10 to the power 23 per mole. Getting used to be familiar to know where to find your answer. Right? 20 times atomic mass unit. 20 atomic mass unit. So times this one is 1.66 and 10 to the power minus 27 kilogram for one atomic mass unit. Then you change the kilogram, becomes kilogram. Okay.
Yes.
Okay. Ions in C are accelerated from rest in vacuum through a potential difference of 1400 volt. They are then injected into the region of space where there are uniform electromagnetic field at right angles to the original direction of motion of ion as shown. This is your velocity selector. The electric field strength, the electric field strength has a the electric field has a field strength of E, and the flux density of magnetic field is B. Copy 6.1 on the diagram and indicate clearly the direction of electric and magnetic field so that the ions are diffracted in the region. Well, I choose for you one. Magnetic field. Okay.
Yeah.
So where's the force? Where's the electric field? I choose for you the magnetic field already. So you should be able to get the force on the neon ion. Where's the force?
Looks like up lah.
Okay, upwards. And where's the electric field?
Electric field, right hand side.
Oh, you want velocity selector can be right hand side.
Oh wait, what?
You want it to go straight through. Magnetic field is upwards. Magnetic force is upwards. So electric force must be downwards. Yeah, acting on the positive ion. So electric field must be coming down. Like that. Can or not? Can see the reasoning.
Or is it the normal to the force? No,
The magnetic
no,
force
not.
acting on the ion is upwards. So the electric force must be downwards. So
Oh, it's what do you call it? Reaction.
not reaction force, it's just velocity selector.
Oh, okay.
Right? So if the electric force is downwards, then the electric field is acting on a positive charge must be also downwards. Okay, now make sure you know how to do that.
Yep.
Okay, if you're all right, then carry on. Calculate the speed of the accelerated ion on entry in the region of electric and magnetic field. Right? That's the info given you. How to calculate the speed of the accelerated ion. Use EV. EV is half mv squared. Should be able to calculate the speed now. Mass you have already calculated. Charge, you already know the charge. Right? One positive charge go to electron, charge an electron, and 1400. Right? The ion has one positive charge, half 20 times atomic mass unit is 1.66 and 10 to the power minus 27 kilogram, and speed, velocity. Right? Ion, neon has 20 in a 20 nucleon. Can
Yeah.
electric field strength E is 6.2 times 10 to the power 3 volt per meter. Calculate the magnitude of the magnetic field flux density so that the ions are not deflected in the region of the field. For electric field equals magnetic field, and calculate the B. Electric force equals to magnetic force, right? EQ, Q and Q cancel off. E is given. Speed, we have calculated it out. And then B, can, can or not. Anything not clear?
Yes. It's alright.
Okay. Okay. The mechanism by which the ion atoms in C are ionized is changed so that each atom loses two electrons. State what change occur in the speed of the ion entering the region of the electric and magnetic field. Any change? Increase, decrease, unchanged? State only.
Uh, speed is decrease.
Why decrease?
Wait, what? Uh-huh.
As
Oh,
the charge increases, V and M is constant, the velocity of ion entering the region increases. Velocity increases, speed of ion entering the region increases.
yeah, they're directly proportional.
Path of ion in
It,
the two field.
so it's unchanged.
If the speed increases, right, BQV will increase. So it's greater than electric force. Magnetic force is greater than electric force. So the magnetic force is greater than electric force. Thus the ion will be deflected outwards.
Oh,
Okay?
okay.
Okay. This is an old question. Figure 3.1 illustrates the pattern of magnetic flux due to current in a solenoid. On figure 3.1, draw arrows to show direction of magnetic field in the solenoid. Yep. This one is current into the plane of the page. This current coming out. Can?
Oh, yes.
Yeah.
Using the right hand rule.
Right hand grip rule. So what is the direction?
Uh,
That's all. Yeah. Can or not?
yeah.
Right hand grip
Oh, okay.
using the thumb as the direction of the north pole or the arrow. Can or not?
Right.
Draw a line to represent the current carrying conductor in a magnetic field which does not experience a force due to magnetic field. Where should the current carrying conductor be placed? Perpendicular, at an angle, parallel. Right? Do you want the conductor to experience a force? Perpendicular, inwards, or what? That way, like that, that's all. Right? Parallel to the field, no force. Only at an angle there's a force. Okay now.
Mm-hmm. Yes.
Coil of wire on an electromagnet are usually worn on ferrous core. State two properties of the core which are important in its use as electromagnet. Yep,
Okay.
electromagnet.
What's, wait, easily to magnetize, is it? Is that one of them? Easier to magnetize and demagnetize. I think I remember this from SPM.
One is correct, but it does not retain its magnetism. That's one of them. It concentrates,
Demagnetize.
it concentrates the magnetic field, thus increases the magnetic field strength or magnetic flux density. Okay, does not
Yes.
retain its magnetism. Okay,
Yeah.
right, let's try the one I sent you. What what is represented by the symbol N? Magnetic flux density B is normal to the surface PQ
Yeah, you can.
of the slice of conducting material as shown. The current in the slice is normal to, right? That's the current.
N is the number of the density of the charge carriers.
Okay. Number per unit volume, important, of charge carrier or free electron.
Can I say density?
Better explain it lah. Number per unit volume. The symbol T represents the length of one side of the slice. Use the letter from figure 9.1 to identify T. Where is T?
Put XY.
XY? No, always parallel to the field. Thickness. Always
Oh,
thickness is always thinner. Right? Tx or Qy or Rz. In general, Hall voltage produced in a slice of metal is very small. For a slice of same dimension with the same current and magnetic flux density, the Hall voltage produced in semiconductor is much larger. Suggest and explain why. Right? They give you the formula. They expect you to reason it from the formula.
voltage inversely proportional to N, the
Inversely
density.
to N. So yeah, there, but you haven't explained completely. N in semiconductor is smaller, right? VH is inversely proportional to N. For semiconductor, N is much smaller than that for metal. Okay,
Yep.
in some semiconducting material, electrons are mainly responsible for conduction. In some semiconducting material, holes are mainly responsible for conduction. Suggest and explain the difference, if any, that that conduction by electron and holes will have to have on the whole voltage. Right? Suggest and explain the difference. Right? Magnetic field will deflect holes and electrons in the same direction. Because electrons is negative, holes are positive. So VH polarity, VH is opposite polarity. Okay,
Yes.
don't have much time already. Yeah, thought I could. Right, you should be able to define Tesla. I go very fast. Right, there's definition for Tesla based on this formula. Right, charged particle of mass m and charge q is traveling with velocity v in vacuum. It enters a region of magnetic field of flux density b as shown in figure 6.1. Magnetic field is normal to the